Alright. Power reducing identities is the only new idea I wanted to take a look at today. So write these down. We have a way to change second powers of sine, cosine, and tangent into first powers. So sine squared is equal to 1 minus cosine of 2x over 2. Cosine squared is equal to 1 plus cosine of 2x, 2. And tangent squared is equal to 1 minus cosine of 2x over 1 plus cosine of 2x. And now, if we think about a few of these, right, these end up just being manipulations of our double angle formulas. For example, on this one, if I multiply both sides by 2, I would have 2 cosine squared of x equals 1 plus cosine of 2x. And if I subtract the 1 over, I have 2 cosine squared of x minus 1 equals cosine of 2x. Okay, that's one of our double angle formulas. Okay, so these all end up just being manipulations of the double angle formulas. And so we're just kind of turning them around so that we can look at reducing squares of our trig functions into powers of 1. These ones you do not have to memorize.
Can we just not avoid memorizing these ones?
Too bad.
I thought that.
Nope. Alright, we have these written down. So we can use these to do something like this, okay? Write an equivalent expression for cosine to the 4th power that contains only first powers. Okay, so the first steps are written out here, okay? I can first say that cosine to the 4th is equal to cosine squared squared. Okay? I can split cosine to the 4th up into cosine to the 2nd power. And then our power reducing formula on cosine to the 2nd power. And so we know cosine to the 2nd power is just equal to 1 plus the cosine of 2x all over 2. I would probably write it down. Alright, so what they did was they squared both the numerator and denominator and then pulled the denominator of 4 out as a fraction of 1/4. Okay, so if we square the numerator, 1 squared is 1 plus 2 times the product of the 2. So 1 times cosine of 2x times 2. And then square cosine of 2x. Okay, so now we still need to reduce cosine squared of 2x. Okay, we have a 2nd power. We want our final answer to only contain first powers. So we can use our power reducing formula again. If I take this now, up here. So we've got 1/4 times 1 plus 2 cosine of 2x plus cosine squared of 2x. Okay, if I use my power reducing formula here, we can just say that this is equal to 1 plus the cosine of, and I'm just going to double this angle. Right? That's all we're doing to get from cosine squared of x to here. I'm taking 2 times whatever this value was inside of here. So if I'm using my power reducing formula on an angle that was 2x, I'm multiplying that by 2, this is going to become 4x. You okay with something like that? So if we're using the power formula, we've got cosine squared of x. It'll look like this. 1 plus the cosine of 2 times x over 2. But if I have something other than x in there, in this case we have 2x on the inside of cosine squared, all I'm doing when I'm using that power reducing formula is multiplying whatever that was by 2. Okay? So this could be our final answer. Right? This is everything written in terms of a first power. But if we wanted to clean it up a little bit, we could distribute the 1/4 out and say this is 1/4 plus 1/4 times 2 would be 1/2. 1/2 times cosine of 2x plus. So here I would have, if I distribute the 1/4 over here, 1 plus the cosine of 4x over 8. 1/4 times 2 here would be 1/8. Then if I split this up, okay, since I've got a single denominator, I could write this as 1/8 plus cosine of 4x over 8. And the reason I'm doing that is so that I can combine my constants here. I have a 1/4 and a 1/8 that I can simplify into one term. So 1/4 plus 1/8, well, that would be 2/8 plus 1/8 would be 3/8 plus 1/2 times the cosine of 2x plus, and I can just make this so that it all looks the same. Instead of divided by 8, I'll pull a 1/8 out. Right, so in terms of actually answering the question, we could have actually stopped here, right? Because it just says, right, an expression that contains only first powers. So technically, this step satisfies the conditions of the question. Right, but to make it a little bit nicer, we can simplify that. Right. Questions on something like that? It can make solving some equations a little easier. Where you lost? Can't say everywhere.
Just
No, I literally have no idea what you did.
mainly just what you wrote on the board just now. So, like, are you using that last identity for that?
What last identity?
The one at the bottom, the 1/4 distributed.
Yeah, I just copied that down here and then went from there.
What were you solving for? We just simplified.
Just simplify. I mean, like from here to here, we did have to go one step further to reduce cosine squared. We can't have, it says, we only want first powers in our final answer. So I used the power reducing formula to reduce this into a first
I
power.
thought you were trying to solve for something. It's like when we had to verify the identities or just simplify it.
Yeah, kind of like that, yeah.
Okay.
Alright. Other questions on something like this?
What?
Well, let's try another one. How about what if we do something like, so what? What if we just do sine squared times cosine squared? Use the power reducing formulas to write this with only first powers.
Wait, is that as simple as it goes?
No, because we still have to reduce this now.
Oh, wait, is it?
Because we can reduce it further.
What would that mean?
It's not simplified.
So, because they have different signs, the middle bit of the foil is canceled out. They don't want to.
Yes, because we still have a cosine squared.
What do you do to get rid of the 4 on the bottom? Do you multiply by 4?
You mean in the next step?
Yeah.
Like, so we'll have
Yes.
1 minus.
I'm literally having the biggest brain fart.
So dividing by 4 is the same as multiplying by 1/4.
Thank you.
So.
How'd you get that?
Cosine squared is the
Think
same
I got
as 1 plus cosine of 2 times the angle over 2. So 2 times 2 theta.
Does it have to all be one term or can there be 2 terms?
You can write it as 2 terms.
We'll see if I did it right. Is it 1/4 minus 1 plus cosine of 2x over 8?
Wait, say it again.
1/4 minus 1 plus cosine 2x divided by 8.
It should be cosine of 4x, right? Because if we're doubling.
Oh, yeah. But the rest of it's right.
I think so. I read it like that.
And that would be good then.
Yeah. Yeah, we could write it like that. We could go a tiny bit further and combine these.
Yeah. But how would you do that? Oh, you just multiply from the top and bottom by 4 and just add them. Or by 2, sorry.
Yeah, so we can make this 2/8.
And then you just have 3 plus cosine 4.
No, we'll have, so 2 minus 1
Oh, my bad.
would be 1. Sorry. So that would end up being 1 minus cosine of 4 theta. That negative sign.
Wouldn't it be plus though?
So if we're subtracting, we'd have 2 minus 1, we combine those like terms, but then that negative would still need to be distributed to the cosine of 4 theta as well. So we're just thinking about it like this.
Oh, okay. I'm just gonna leave it where I had it.
just moving from that to the next one. And then when you times it by 1/4, like and then you mark it after that.
So from here to here, I just split this up into two fractions. So if we have a single term in the denominator, we're allowed to just say, well, that's going to be 1/4, and then put all of this over 4. So when we're doing that, if I'm dividing by 4, that's the same as just multiplying by 1/4. So that's how I get 8 in the denominator here, 2 times 4. Then, so I just combine these into a single term. So I just over here, so I multiply the top and bottom by 2 to get 2/8. And then if I do the subtraction, 2 minus 1, it will give me 1, and then negative cosine of 4 theta. We okay with this one?
I'll figure it out eventually.
This is the last section of the structure.
This is only the third section.
Oh my god, I thought you said this was only 3 sections.
I said this whole semester is only 3 chapters, but in each chapter there's 6 or 7 sections.
I thought you said there was 3.
All right. How about?
Just wait till the final test on this.
Mr. Feathers,
The,
one more thing. Where did that 2/8 go on the second to last step?
2/8. So
You combine it.
yeah, I just combine these fractions. So, and in the numerator, I'm just combining like terms. So 2 minus 1, 1, and then negative cosine of 4 theta. Let's try simplify another one. About how about just sine to the 4th power? So we did cosine to the 4th. How about sine to the 4th?
Oh, dude. And I've said about I will let you go.
Well, the first thing that we did when we did cosine, we wrote this as cosine squared squared.
Yeah.
So let's start with writing this as sine squared squared.
And then you just gotta multiply all this crap up. Exactly for you. simplify this thing further after I get it down to 0 squared, like no squared things.
So are you like to here? Or I mean, if you have the 1/4 pulled out,
Yeah.
it would be the same thing.
So I have that's wrong.
No, I just reduced the 2 before.
So I
Yeah, so you're in the same spot.
so I'm actually
What's that trick you did before?
Except, except I didn't that's for it. I messed up.
wait.
Yeah, let's see. I did. I just realized I messed that up. Yeah. Oh, the square, squish and double thing.
Correct.
So if you're squaring a binomial, say it's x plus y squared.
Yeah.
The shortcut is square the first. You could. There's a couple ways you could say it. Sometimes you could say it. Sometimes it's called square, square, squish and double. I always heard it as square the first, take 2 times the product of the 2. So multiply these together. So x times y, and then times 2. So plus 2xy, and then square the last.
So could I just left it at stuff where it was?
Right here.
Yes.
Yeah. Yeah, that's right.
So I'm struggling with simplifying stuff.
So. So if you've got cosine squared, that 2 theta gets multiplied by 2 again. Right?
Yeah, from here to here. Yeah.
Oh, yeah. I have an 8 here. I think a blood vessel's gonna pop in